Okay, today we are taking the last chapter. So I'll be starting with CNC machines and robotics. So it is with introduction to CNC machines. Uh, the course objective of this is to develop part programming for CNC turning, milling, and verify on simulation software. So as you people know that the lab will be starting soon, the sim lab. You will be having a part programming in that, and as well you have a simulation software. So why we go for simulation is since the tool and the machine both are expensive, even the part if it is of a higher cost, then we cannot just make trial and error methods on it. So we cannot waste the given part. So what we do is we first simulate and check whether the part can be uh, machined, programmed, and other things on the machines, whether the part can be produced. If it can be produced, first we check the simulation. Simulation is just the virtual part of actual machining happening, which will be done on a software. So the contents are introduction to CNC, operations in CNC, advantages, axis selection, 5-axis CNC machine, advantages and applications of 5-axis. We have 3-axis X, Y, Z. 5-axis means there will be rotation about X or Z or Y, either of the two. And then types of machine configuration for 5-axis machines and specification of a 5-axis CNC machine. So introduction to CNC, first is NC, then is CNC, and then we have DNC. In numerical control, it is the automation of machine tools that are operated by precisely programmed commands encoded on a storage medium as opposed to controlled manually. So if you go with a normal lathe machine, we actually control all the uh, parameters, whereas in numerical control, we pre-program, we put the program into the machine, and the machine itself will take care of those parameters. Most NC today is computer numerical control, in which computers play an integral part of the control. In modern CNC systems, end-to-end component design is highly automated using computer-aided design and computer-aided manufacturing, which we call it as CAD and CAM. Operations in CNC, CNC milling, then we have hyper performance, that is plasma arc cutting, we call it as plasma cutter. Then we have CNC electric discharge machining. This also is possible on CNC. Then this is a typical CNC machine. We have the headstock inside, we have the bed here. This has a door. Until the door is closed, the machining will not start, which is actually for the safety reasons. And this is a CNC control panel where the program is fed into this. There is a tool turret which has all the tools which we require, maybe turning, threading, drilling, all the things are here. There is a tailstock and the tailstock quill. Then you have the chuck where the part is fed. Then you have the foot switches, whether to start, stop, emergency stop. We need to do it from here. And this, sorry, yeah. And there is a door here. Until the door gets closed, you cannot start the machine. The door acts as a safety option. Then other CNC operations are CNC water jet cutting, drilling, sheet metal works, that is turret punch. If you have seen the computer systems, the back of the computer panel, that is the desktop box. If you see that, there are a lot of holes. There is provision for USB ports and other things. That entire thing can be done on sheet metal work, that we call it as cutting. Then we have surface grinders, cylindrical grinders, submerged welding, CNC operations, submerged welding. How these things work is, if there is a turbine and you need to go and do something onto that, there will be a CNC machine which it itself is called as a robot that will go and do the welding. Then you have glass cutting. So advantages, the machines can be used continuously. Batch production with high accuracy can be updated by improving the software. Training in the use of CNCs is available through the use of virtual software. Then integrate detail machining. Most of the, if you see the gun, the trigger part, there are small holes into that, and there is a curve cutting. That curve has to fit exactly, or the detailing of that has to be done properly, which cannot be done by a manual work, because every time I'm going to do a new trigger, I'm going to change its angle or something, and uh, all my parts which I am going to manufacture in a human version will be different. Though the dimension will remain same, but the curvature which has to be achieved will be different on each of the part. One person can supervise many CNC machines simultaneously. It saves time. The disadvantages: more expensive than manually operated machines. Yes, because CNC machines are sophisticated machines which are almost like a robot. What you feed to them, they will start working on it. Then the CNC machine operator only needs basic training and skills enough to supervise several machines. In the years gone by, engineers needed years of training to operate center lathes, milling machines, and other manually operated machines. This means many of the old skills are being lost. That is, it's just an example. We used to use drafter, the scale drafter. Nowadays, you are using all the AutoCAD tools to draw the drawing and then take a printout. If there is a problem with one line, what you do? You just go back, delete that line, again take a printout or do something. But during the drafting thing, we used to again sit and see what was the problem, and then go and rub it, and then again redraw. If the entire thing is being in a shabby shape, then again do something which is new. Then investment in CNC machines can lead to unemployment, because if the CNC machine can do a lot of things together in one, this one, so instead of having 10 machines and 10 operators, I will have one CNC machine and one operator. So other 9 operators are going to lose the job. That we It leads to unemployment. Then the access of CNC machine tools, the tool access. Wait 1 minute, I'll just put on the laser pointer. This is the tool axis which will rotate. Then you have the cutter. Then there is a positive Y, there is positive Z and positive X. Then you have the tool path. The work table can also move. The Z axis plane control will be here, and this is the Y axis. So here, rotation about Z, rotation about Y, and rotation about X. These are 3 axes. Movement about X, Y, and Z, there are another 3 axes. So there can be 6 axes. And at all, if the workpiece is going to rotate about the rotation axis, then it will be the 7th and 8th axis. 5 axis CNC. So you have A axis, B axis, X, Y, and Z. There is a rotation here, rotation here, rotation here. So this is a 5 axis CNC machine. I cannot rotate about Z axis. That is, this rotation I cannot do. I can only rotate about X and Y axis. Advantages of 5 axis CNC machine: to machine complex shapes in a single setup, reduce the machine setup time and increase the production rates. By eliminating multiple setups, time and errors are reduced. The feature to features accuracy is improved because the same zero or datum reference frame is used throughout the manufacturing process. That is, if I'm using this 11 number as the datum, so in a CNC, this will never move. So all these points in the space are with reference to this point number 11. Then since simultaneous movement is allowed along X, Y, and shorter, more rigid tools may be used. Higher spindle or cutting tool speeds may be achieved while reducing the load on the cutting tool. Shorter and thicker cuts also reduce vibrations when machining deep pockets or contoured feature with 3-axis machine. So if you have done grooving operation on a lathe machine, you know how difficult it is, what vibrations you get on the carriage itself. So if there are very high speeds, then slowly it is going to get into and do a grooving operation, which is more advanced in a 5-axis CNC machine. Excuse me. Then application: complex three-dimensional profiles can be achieved for impellers, turbine blades, and plastic mold tools. The application is more useful. If you have seen the turbine blades, they are twisted in a particular angle. So either I have to bend it on a die or machine it directly. And if the turbine blades are smaller in size, if I have a turbocharger in a car, then I cannot go with the sheet metal. I need to go for a thicker slot, so which can be done on a CNC machine. The types of machine configurations for 5-axis machining, you can see here. Swivel head with rotary table. So this can rotate. This can rotate. This can swirl around like this. Then integrated Trunnion table. This, if you see, this entire table can be twisted over these two points, and this can be moving up and down. So rotation and up and down movement. In the traveling column means this entire column can travel up and down and back and forth, and this is again, it can be rotated. CNC machines, how do they look like? If you see, this is also a CNC machine. There are servo motors, there is a display console, there is a controller, there are slides, and there is something called as a feedback loop. Why we require feedback loop is whether the job is completed, that is cutting has taken place or no. If it does not know, then it keeps the spindle rotating continuously. Here again we have automatic tool changer. We don't have to go and change the tool from simple turning to thread cutting to grooving. Continuously the tools can be changed. If the programming or the programmer does not change the tool, then we are going to damage everything. So finally, in a CNC machine also, if the program is correct, you first simulate and check it on virtual software, and then finally feed that program into this machine. Then elements of CNC machine. It consists of following 6 major elements: input device, machine control unit, machine tool. Why we require machine control unit is, see, if I have to feed a program, the machine should read it. If the machine cannot read that, then there is no use of just giving a program. You cannot just write a program and tell the machine, yes, do this job. No, the machine has to read the program which you have written in machine language. So you require machine control unit. Then the machine tool, the driving systems. Yes, of course, there will be small MEMS, micro electromechanical systems, then feedback devices, and then display unit. So this is a block diagram of a CNC machine. First is the input device, that is a part programmers. Then we have a display unit. This is a machine control where the data also is processed, and we have control loop unit. Control loop unit is always a closed loop unit because you need to require or have a feedback of whether the machine is being done or no, what type of machining has taken place, whether it is threading, cutting, milling, end milling, all these things. Then from machine control, it will go to the motion data, which will drive the system. Driving system on this machine tool, whether I have to move the spindle or move the work table, what I have to do will be done by this motion data to the driving system, and then machine will be taking place. And there is some miscellaneous function, whether to on the coolant, off the coolant, whether we need to send oil during threading, thread cutting. Cooling oils are also a requirement, so that can be done. And there is a feedback device, so whether the cutting has taken place or whether there is a jam or whatever it is, whatever is happening on this machine, there will be a feedback device which will give the position feedback and the velocity feedback. There will be other feedbacks. If there are more sensors, there will be another set of feedbacks here. Okay, so once the feedback is given, what are the position where the cutting has stopped or where is the velocity of that tool, again the machine will start processing. It will go for the next operation. It might change the tool here. Miscellaneous function, tool changing also is one of the miscellaneous function that will be taken care of. Open loop and closed loop systems. So what is an open loop system? In open loop system, there is a pulse train stepping motor, or we call the stepper motors. Stepper motors are used for angular motions. If I give a 30-degree motion, it will only turn 30 degree. It will come back again, move 30 degrees. So there will be a gear, lead screw, and the work table. So the work table will move back and forth. Now here, there is no feedback given to the main machine control unit. So we call this as open loop system. It is just like I'm opening the door is open, it's done. Whether people come in, go outside, I don't care. But if I put a feedback system to this and put a sensor here, so if you see the glass doors where there is a closed loop system, if there is no person standing, the door will close. If the person is standing, the door will open. If the person walks in, the door will close back again. So it is just like that. In open loop, there is no feedback. In closed loop system, here you can see comparator, digital to analog conditioning, signals, DC servo motors, gears, work table, lead screw. It will be the position sensor. So work table has moved this side or this side. The position sensor will give a feedback. Again, there will be a comparator which will compare whether the table has to still move ahead. In open loop systems, the slide may overshoot or may not reach desired position because of inertia, wear and tear friction, hence inaccurate machining. In closed loop systems, the position sensors are used to correct slide movements and achieve higher accuracy and repeatability. Now, accuracy is something near to 1. Repeatability is doing the same job again and again at the same positions. If it cannot reach the same position again and again, then it has less repeatability. If it can do that, it has more repeatability. Okay. Next, how CNC works. It is controlled by GM codes. These numbers are values and coordinates. Now, you need to have this knowledge because in lab also you are going to do something on this. Then each number or code, sorry, larger machines. Sorry, how CNC works? Controlled by GNM codes, these numbers, values, and coordinates. Each number or code is assigned to a particular operation typed in manually to the CAD machine operators by the machine operators. G and M codes are automatically generated by the computer software. So in Mastercam, if we are doing, what we do is we design it first. We design the model. We specify that here drilling has to take place, here milling has to take place, and the machine itself. So virtual machine, we call it as the software, will automatically generate the G and M codes. G are the preparatory codes and M codes are miscellaneous codes. What are those? We'll read in the next slides. Features of CNC machines. The tool or material moves automatically. Tools can operate in 1 to 5 axes. Larger machines have a machine control unit which manages operation. Movement is controlled by motors, actuators. Feedback is provided by sensors, transducers. Tool magazines are used to change tools automatically. Okay. Uh, the tool or material moves automatically. Tool can operate in 1 to 5 axis. Larger machines have a machine control unit, which you call it as machine control unit (MCU). Movement is controlled by motors, which we also call actuators. Feedback is provided by sensors or transducers. Tool magazines are used to change tools automatically. CNC program basics. CNC instructions are called part program commands. When running, a part program is interpreted one command line at a time until all lines are completed. So when you write a program, there is one entire set. We start with N001 or N002. Then we have the preparatory codes, then the M codes, then the tools, speed, all these things in one single line. So after first line is completed, then it will go to the second line. Commands, which are also referred as to blocks, are made up of words which each begin with a letter, address, and end with a numerical value. CNC programming, important things we should know. The coordinate systems, units, incremental or absolute positioning. What exactly is incremental and absolute? I will be telling in the lab. I'll be giving a demo on that. Coordinates X, Y, Z, Rx, Ry, and Rz. Rx means rotation about X, rotation about Y, and rotation about Z. Then feed rate and spindle speed, you need to know. Coolant control, on off, fed mist. Tool control, tool and tool parameters. Then you have consists of letter codes, preparatory codes, which are called as G codes, initial machining setup and establishing operating conditions. N codes specify the program line number to be executed by the MCU. This line numbering, what we do is, if I type N001 as first line, my second line addressing would be N005. So if I have forgotten any line to specify, so in between I have still 2, 3, and 4 line numbers, which I have not written, but I can still input. But if I write it as N001 and N002 and I have forgotten some line, I cannot put as N001.5. There is nothing called as 1.5. So I need to leave some space to input if one line if I have forgotten or if there is some problem with the machine. Then you have access codes XYZ used to specify the motion slide along X, Y, and Z directions. Feed and speed codes, that is F and S, specify the feed and spindle. Tool codes T, that is it should specify the tool numbers. If T1 stands for V tool, T2 may stand for grooving tool, T3 may stand for some other tools. But these tools are specific to the turret or the tool envelope. We need to know that the tools are in the right envelopes only. In shelf number 1, if you keep tool number 3 and shelf number 2 you keep tool number 1, then this will go wrong. You need to be perfect to keep those on the CNC tool magazine. Then miscellaneous codes, M codes for coolant control and other activities. Then common format of a block. First will be the sequence number N50. It may be N01 also. Then preparatory function G90, G01. Then dimension words, how much moments, that is X 1.4 units and Y 2.25 units. Then feed rate is 10. Spindle function, that is 1500 RPM. Tool function is tool 01 will move at a rate of 1500 RPM with feed rate of 10 millimeters per minute with the dimensions of X 1.4 and Y 2.25. Then miscellaneous function M03 is spindle start, that the tool has to rotate. So it is spindle start M03. So altogether is one individual words which become one single line block. Then programming key letters. These are different programming key letters where O is a program number. Sorry, it is actually 0. Right? Here it is written as O. N is the sequence number. G is the preparatory function. These are X, Y, Z. R is radius, feed, spindle. H is the tool length offset. D tool radius offset. T tool designation, and M is miscellaneous function. In most of our programs, we are not using H, D, and this program number. Our program number starts with specific to our machines. We have Fanuc CNC in our IIPC cell, so we are going to use Fanuc programming. If I'm using a Siemens CNC machine, then I will be having a Siemens controller, which will be a Siemens programming technique. Most of this will be common. Some keys may change. And important G codes, this you need to keep in mind. From G40 to G49, you do not, but other things you need to keep them in mind, or you need to buy it. G00 is rapid traverse, that is from the tool. Initially, if you see on a lathe machine, when I'm moving the tool, until before I touch the part, I'm at a rapid traverse. But the moment I touch the part with the tool, then I will be slowly moving it. So G00 stands for rapid traverse. Then you have G01 as linear interpolation, 02 circular interpolation, that my tool has to move clockwise, 03 CCW. Then you have inch units, metric units, cutter tool compensation, scan cycles, drilling cycle. Drilling cycle means I have one hole here, one hole here, one more here. All these are with identical dimensions and diameter. Then I can use a drilling cycle, so that one tool will go drill, come out, again go drill, come out, go drill, come out. It will do. Then you have G92 absolute positioning and incremental positioning. So what are these two? I'll be taking in the lab class itself. Then important M codes, M00 program stop. This can be M30 also. Here M00, it may be machine specific. You can see here M30 is program stop. Yeah, I can use M00. It depends from machine to machine. Then M01 optional program stop. Here, two or three things are common. That is spindle start clockwise, counterclockwise. M05 spindle stop, tool change. These are common throughout all the machines, whether it may be Fanuc, Siemens, or General Electric or Rolls Royce. There are different CNC machines, so for them, most of the M codes will remain common. The advantages of CNC: easier to program, easy storage of existing programs, easy to change a program, avoids human errors. Human errors will be only on the CNC programming, that too because of the virtual simulation. We come to know whether error is there or not, and we can take out that error. They are safe to operate, complex geometry is produced. Then usually generates closed tolerances than manual machines. So this is about the CNC machining. Next one is, sorry, next one is robotics. I'll continue the class till 1:15. I'll finish off this. So there is an introduction to robotics. Common view: robots as humanoids. What can a human do? Same thing can a robot do, but robots are still controlled by humans. These are programmed. If the robot completely communicates by itself everything, then it is actually impossible to completely give the emotions and everything. Whatever you have seen in films, those robots are actually difficult to manufacture. That when Rajnikant film the Chitti, that it does not happen really in actual reality. Robotics timeline. In 1922, Sage author Karpel wrote a story called as Rossum's Universal Robots and introduced the word robota, meaning worker. 1954, George Devol developed the first programmable robot. In 55, Denwitt and Hardenberg developed the homogeneous transformation matrices. That is how the robot has to move and how it has to transform from one place to another. Then innovation was formed, first industrial robots appeared. In 1973, Cincinnati Melcron introduced the T3 model robot, which became very popular in industry. It was acquired by ABB. Now, ABB is the leading robot manufacturer. You know about this. Robot classification. The following is the classification of robots according to Robotics Institute of America. Variable sequence robot (VSR), a device that performs the successive stages of a task according to a predetermined method, easy to modify. Then you have uh, playback robot. A human operator performs the task manually by leading the robot. That is the playback. Then you have numerical control robot. The operator supplies the movement program rather than teaching it the task manually. Then intelligent robot, a robot with the means to understand its environment and the ability to successfully complete a task despite changes to the environment. This is something we call it as automatic robots. So it will adapt to itself. So you literally can go through it. Then defined by robotics, a reprogrammable multifunctional manipulator designed to move material, parts, tools, or specialized devices through variable program motion for a variety of tasks. It possesses certain anthropomorphic characteristics, that is a mechanical arm, sensors to respond to input, intelligence to make decisions. Then next comes is the robot configuration. Some of the commonly used configurations in robots are Cartesian or rectangular type. These robots are made up of three linear joints that orient the end effector, which are usually followed by additional revolute joints. So if you go with the rectangular or Cartesian coordinate system, you can move X, Y, and Z, thereby creating a rectangle box kind of a thing. So the robot can move in the X, Y, and Z direction. So the final envelope, work envelope here, a rectangular box shape. Then the Cartesian robot work envelope, if you see, this is plus minus, so it will be vertical stroke, horizontal stroke, and vertical reach. So if I take the side, this one, it will look like a rectangular box. Or it can also be a square box depending on how the length and breadth of the strokes are given. Then cylindrical coordinate robots have two prismatic joints and one revolute joint. So prismatic joint is, it can move in X direction, it can move up and down, that is the Z direction, and across the Y axis it will go into rotate. So one revolute joint, that is the rotation, and two prismatic joints. Okay. The cylindrical work envelope, what it will be, it cannot move the arm completely 360 degrees. So this is what it can move. So the arm can move front and back, and it can move cylindrical, or it can rotate, and it can move up and down. So the total height will be the same. There will be one chord angle which it cannot reach. Robot configurations, this is the continued part. This is a spherical joint, 2 RP, 2 revolute, and 1 prismatic. They follow a spherical coordinate system which has, this is a rotation, that is the axis, it can move in this direction. Okay, this can rotate, and it can move front and back. So Y axis and X axis it will rotate, and Z axis it will move back and forth. The typical configuration is shown here in the picture. In spherical robot work envelope, it can move front and back, this same thing as cylindrical, and it can move at an angle. So there will be something created here. Then articulated or anthropomorphic, 3 revolute joints and articulated robot joints, all revolute similar to a human's arm. So it will rotate about X, Y, and Z axis. So this image is shown what an articulated robot configuration is. So the first configuration is Cartesian robot, second is cylindrical configuration, third is spherical configuration, and last one is articulated configuration. Then you have one more where it is called as selective compliance assembly robot arm, that is the SCARA. It has 2 revolute joints and 1 prismatic. 2 revolute means there is 1 revolution here, another revolution. Prismatic means it can move up and down. Now control methods. Now how to control these robots? There is a non-servo control implemented by setting limits or mechanical stops for each joint and sequencing the actuation of each joint to accomplish the cycle. Endpoint robot, limited sequence robot, bang bang robot. Bang bang means If I have to spot weld at certain places, it just I need to move the table and it will just go on doing the thing. Then no control over the motion at the intermediate points, only endpoints are known. Then programming accomplished by setting desired sequence of moves, adjusting end stops for each axis accordingly. The sequence of moves is controlled by a sequencer which uses feedback received from the end stops to the index to step in the program. Low cost and easy to maintain, reliable and relatively high speed. Just a minute. Sorry, I have a call. Relatively high speed, repeatability of up to 0.01 inch, so you can calculate how much it is into millimeters. Then limited flexibility, typically hydraulic and pneumatic drives. You cannot have manual drives with the gear and pulley mechanism. You need to either have hydraulic or pneumatic drives, just like you control the JCBs or Caterpillar's arms. Then servo control, point to point control, continuous path control, closed loop control used to monitor position, velocity, and other variables of each joint. Point to point control, only the endpoints are programmed. The path used to connect the endpoints are computed by the controller. User can control the velocity and may permit linear or piecewise linear motion. Feedback control is used during motion to ascertain that individual joints have achieved desired location. Point to point means if I take my wrist, I need to move one object from left to right. I just pick it up and keep it there. So that is the point to point control system. Often use hydraulic drives, recent trend towards servo motors, loads up to 500 lb and a large reach. Applications, pick and place type operations, palletizing, machine loading. Machine loading means I need to pick up a part and load it in the machine. Most of the times these robots, pick and place robots, are used in nuclear reactor where I need to put the reactor rods into the nuclear reactor envelope. Then continuous path control. In addition to the control over the endpoints, the path taken by the end effector can be controlled. That is the applications, spray painting, polishing, grinding, arc welding. Continuous welding also comes under continuous path control, where I need a continuous line. I cannot pick and place, but I need a continuous line where I need to track. Then we have two or three types of what is called as resolutions, then what we call as accuracy, and what is repeatability. The smallest increment of the motion at the wrist end that can be controlled by the robot depends on the positioning control system, feedback measurement, and mechanical accuracy. So this is the target point. This is the end effector, that is the robot arm. Position A, one possible position A, and then adjacent position. If this end effector can move in between these two and reach the target position, then it has a very good resolution. But if it cannot, then it is of no use. Now, the very good example of this is on your Android mobiles. When you start moving one icon on the screen, you want it at exactly one particular point. It does not go and fit there. It slightly move on the left or on the right side. It will go and fit into that resolution point only. It will not. It will not fit where exactly you want it. That is what the resolution means. Then you have accuracy, capability to position the wrist at a target point in the work volume. That is one half of the distance between two adjacent resolution points affected by mechanical inaccuracies. Manufacturers don't provide the accuracy because it is hard to control. Now, the resolution was from here till here, and if I can still reach the target point, then that is accuracy. Sometimes I can move up till this point. Sorry, I put on the laser pointer. I can move till this point before the target point, so it is less accurate. So accuracy goes on decreasing over time, and you need to recalibrate the mechanical or the robotic arm. Then repeatability, ability to position back to a point that was previously thought. Errors from a random variable, mechanical inaccuracies in arm wrist components. Larger robots have less precise repeatability values. That is, I need to move to this repeated point R continuously every now and then. There is a target point. And the actual point achieved is this point. So whatever the distance is, that is called as a repeatability error. uh, Example, if I tell you to throw or keep a duster from the bench to the blackboard, you will do it 50 times, 100 times, then slowly you have a fatigue and you start throwing from one point, then finally the duster is falling somewhere else. So that is called as a repeatability error. End effectors, device attached to the robot wrist to perform a specific task. Now this entire thing is assigned to hold a cylindrical part. So there will be a gripper into this. There will be whatever the release wire, how to operate and all will be shown here. Grippers, mechanical grippers, suction cups or vacuum cups. If you have a non-magnetic material to be picked up, you can have suction cups or vacuum cups. If you have a magnetic material, you can have magnetized grippers. If you have something to hold on, you can have hooks. If there is some fluid to be picked up, you can have scoops on the robot end arm. End effectors, device attached to the robot wrist to perform a specific task. It can be spot welding gun, arc welding tools, spray painting gun, drilling spindle, grinders, wire brushers, heating torch. It can be anything. So here it is a typical spray gun here. So it is spraying something onto the part. Then sensors in robotics, there are different types. Tactile sensors, that is the touch sensor, force sensor, tactile array sensors. Then proximity and range sensors, optical sensors, acoustical sensors, electromagnetic sensors. Proximity and range sensor, because it usually the proximity sensors used in a car reverse parking. If you see the circular dots at the end of the car, at the rear on the bumper, they're all proximity sensors. They calculate the distance and sense how much is the object in front of, how at what distance the object is in front of it. Then miscellaneous sensors, that is transducer sensors, which sense variables such as temperature, pressure, fluid flow, thermocouples, voice sensors, all this. And you have then machine vision systems. Uses of sensors for safety, interlocks will work cell control, part inspection for quality control, determining positions and related information about objects. Then desirable features of sensors: accuracy, operation range, speed of response, calibration, reliability, cost, and ease of operation. The speed of response is the sensor's speed usually goes in micro milliseconds. The moment there is an object and the robot has stopped, with the help of proximity sensors, there is a feedback control. It will give an alarm that there is some object in front of it. Either there will be a human intervention to remove it, or there will be one more robot arm to take that object away. So this was about the chapter 5, the CNC and robotics. We have completed the syllabus till today. So from tomorrow, for my division, that is for C division, they need to start presenting. Whoever is ready can start presenting, and for presentation, the leader has to send me a mail of his PPT after presenting, and also the recording. We need to sit and record these sessions because we need to forward it to the session coordinators. So today is the end of the syllabus. that is about this one. And maybe next week we will start recording the sim lab sessions, and we will post it in the classrooms. I hope everyone is joining the classrooms for sim labs. So we'll post it in all the 4 divisions. I'll be taking the demo, starting demonstration of how to use the software, and the later exercises are being divided with 4 of the professors. So they'll also be uploading the video in the classroom. So you need to go through that, and if you need to have an installation, we will soon share the software from the drive, because either you have to come down and pick up the software, or we need to share it somehow. How to install also will let you know in the classroom itself. Okay, have a great day. Thank you.